Hi, Classpad.net users. I am going to be talking about composition of functions today, and I'm going to show you how to define functions and then create the composition and then also graphically show it. Once you've defined it, you can use it in several different stickies. So I'm first going to define some functions because this makes things a little easier. I'm going to go into calculate, and let's define three functions so we can just talk about it. So f of x, and to define a function, you're using this colon equals. It's telling Classpad.net that this is what I want that function to be. Whenever I use it, you are to refer back to that. So 3x, let's make this one quadratic just for the heck of it, plus 5. And so you'll notice when I hit enter, nothing's happened because I've simply defined that function to be 3x squared plus 5 all the time. I'm going to use it. If I use it in a graph, that's what it is. So that's very helpful if you're working with students. Say I want to have them evaluate a function at a specific value. Since I've defined the function, I can now just tell me what f of 3 is. Whoops, helps if I use parentheses. So since the function is defined, it is simply substituting that 3 in for the x variable and evaluating that function. So that's really nice for students to see. And so let's define a second function. So we've got, let's do f g of x, and we're going to, again, colon equals to define it. Let's make this one linear. So again, I've defined it, and let's just see. If I've defined it, let's substitute in 3 for x. And what's the value of that function at 3? And I get 3. So you can see that the Classpad.net is defined each function, and it's using that function to help it evaluate. So now we can think about compositions. What is a composition? It's when you take one function and plug it in for the value of the variable and work out that second function. So if I do f of g of x, whoops, students have a hard time with kind of visualizing what's going on, but the nice thing with Classpad.net is it's going to actually show them what happened. So when I hit enter, it's saying we've taken this function g of x, so let's go back up here. Here's that function g of x. We've plugged it in to the function f of x. So here is the function f of x. So every time I had a variable, I plugged in the entire function of g, and now we can evaluate it. So let's see what the difference is. If I evaluate this composition of functions at 3, what answer do I get now? Well, basically what I've done is I've taken this value of 3, plugged it into g first, then evaluate it again for f. So composition of functions. So let's do the reverse. What's the reverse? What if we do g of f of x? What's that look like? Is it the same? It's not, so let's compare them. So again, we're taking the function f and plugging it in for the variable x in g. So this is the whole function. So now let's see what the composition of g of x at 3 is equal to. So notice we get different answers here. And so this is really nice for students to explore. I could have many functions defined. I could do composition of 2, 3, 4 functions. We're not going to do that. I'm simply showing you how to easily do composition of functions. Let's think about the graphs now. So let's go into graphing. And since I've already defined the functions, right, I already have f defined, I've already have g of x defined, I can now also graph them. So let's just see what it looks like. So I'm going to graph f of x first. It already knows they're attached. Remember, we're talking to each other, so here's that, and maybe we want to zoom in a little so we can see it better. Get it down here. There we go. And now let's graph what g of x looks like. Right, so there's the linear function. So now what's the compositions look like? So let's do f of g of x first. Oh, sorry, I forgot to put my y equals. Right, so it's also quadratic. It makes sense, but we've plugged in the whole function of g in for x and then evaluated. So now let's change this color here. I like them to stand out a little bit more. So let's do y equals and do the reverse, g of f of x, so we can visually see the difference. So quadratics here, which makes sense because I'm working with at least one quadratic. So I'm always going to end up with quadratics when I compose them. So here is the actual values of what's going on, and here's the graph. So that's two different ways to think about composition of functions. And I want to just add in, let's say we have, what happens when you have composition of functions equal to the identity function x. That's when you have inverse functions. So I'm going to, again, define two functions, and let's give them different values here. So I'm going to define a function to be 2x. We'll just start with linear just to make it easier. And then let's define another function, let's do j of x, and define it to be so I have these two functions, right? And notice, nice thing about Classpad.net, it will keep things in standard form. You could have it in its decimal form, but that doesn't help you actually see the inverse relationship, and we're going to get back to that. So I like that we can show the standard form in its actual correct form. So now I've defined my function. So now we can look at what is the composition of those two functions. So let's do h of j of x. When you're working with students, when they do this, and wow, we get the identity function x. So let's see if that's true if I do the other way of composing these two functions. And it is. So since the composition of both is the same, I get the identity function. These are inverse functions to each other. What's that look like graphically? So let's actually pull up another graph here. And there we go. And let's graph each function again. So we're going to do y equals h of x first. Whoops, I added a little extra 0 in there. Didn't mean to do that. Notice it gave me a slider because it didn't recognize it. And let's do the other one, which we said was j. So here's my two functions, right? And they're both linear. And so the composition, what's that mean? So let's do their composition both ways. So we're going to do h of j of x first. And notice the composition of them is kind of like right down the middle, inverse, right? So this is showing that these are inverse functions to each other when their composition is the identity function. So let's do the reverse just to kind of verify this. So j of h of x. And notice it's right on top. I now only see one, but I do have 4 graphs here, and this is where it's really nice that you can then separate out. Let's separate out the two composition functions. So here's one of them, and let's pull out the other one. Whoops, I accidentally added it back. Let's pull, there's the first one, and let's go back up here and pull out the second one and look at them side by side instead of on top of each other, since on top of each other they were kind of hiding. So notice what's happened here is I have this composition of function both ways, right? And I get the same graph. So that is showing me that these are the identity function. They are inverse functions to each other. So that's a nice exploration. So then you could even then go from there, what is an inverse function? Those types of things. So just a couple ways to think about composition of functions. You could really do some exploration with just what does that mean when you're composing functions, and then what does it visually look like graphically. You can do it all on the same page, pull things out, and have students make some discoveries. So have fun playing.